Olá pessoal, este vídeo é o primeiro de uma série de 7 que iremos apresentar nas próximas semanas. Todos filmados utilizando a revolucionária e fantástica tecnologia de processamento de vídeo Motion Amplification da RDI. O apresentador será o CEO e fundador Jeff Ray. Acompanhe-nos nas redes sociais LinkedIn, Facebook e YouTube.
Okay, so the title of this talk is motion amplification. It's becoming more than just videos, and the kind of idea behind that is this idea that motion amplification is a big part of what the irism does, and it's sort of the in some sense a foundation of the technology. But as the cameras become more pervasive in different industries, as they are within reliability and in other industries, the technology increases, capabilities increase, and what you can do with them increases. And so we're fortunate that we focus on cameras, and that's an emerging technology. They've been around for a while, but they're really pushing the boundaries. At least digital cameras are really pushing the boundaries, sort of in what they can do. So I wanted to while there's going to be a flavor of motion amplification in this talk, of course, I wanted to really talk a little bit about some of the other things that cameras can do, because there's a lot more that cameras, a lot more problems or tools that cameras can do when it comes to reliability and predictive maintenance that we can leverage. And so that's what we're going to talk about here. So just a little bit for those of you who have never had the pleasure of meet or don't know who I am. I'm CEO of RDI Technologies. We focus on motion amplification and camera-based technology for vibration. And my background's in physics. Started in astronomy and quickly made my way into an industry where I could actually earn a living, and applied what I was doing, in a different field. And so those two things may seem very different from each other, but they're remarkably similar in that the tools are the same. The rules and laws of vibration and physics don't change. And so in one case, you're looking at stars and they're light years away. In another case, you're looking at a motor pump that's a few feet away. And so all you can do is use the camera to get information about what you're looking at. And so we do that now with motors, pumps, pipes, all kinds of stuff. So originally, a lot of the technology was DoD, defense related, for surveillance, and that sort of took a life of its own. And some of that came out for DHS, Homeland Security, for looking at bridges, and you can see how that would evolve into vibration. And then I found my way over in condition maintenance and worked with a large service group, and to bring products to market, and went into RDI full time. So it's a little bit of a history, but let's take a step back here and just talk a little bit about motion amplification and what it is. So you'll see some videos in this presentation. I'm going to do some live demonstrations as well. One of the things that I wanted to also just point out, and Maureen sort of touched on that in the sense that we're over the internet and we're at the mercy of bandwidth and things like that. So some of you may see fluid videos, and some may see a little bit of choppy videos based on your internet connection or sort of where things are routed. So just rest assured that if you see a video, they all should be fluid, and if they're not, then you can wait to get the the YouTube video if there's one in particular that you wanted to see, and that should be posted and you can watch it there. So what is motion amplification? So it's essentially turning a camera into a vibration sensor, a displacement sensor, where you take millions of pixels and you turn them all into sensors. And then we measure motion everywhere. And we do that very quickly and very efficiently. And then we can do something like this, where the left-hand side is the regular video and the right-hand side is the motion amplification video that lets you see see the motions, because once we can quantify them, we can make them bigger in the video. So sort of like what a high-speed camera does. A high-speed camera lets you see things that are too fast to see. We show you things that are too small to see. So if motorcycles are your thing, you can kind of see this. So that's a Harley under motion amplification. So just kind of relating it back to vibration. In a nutshell, this is sort of what we're doing. We're taking this concept of a spectrum, which is, sort of, maybe difficult to understand depending on your level of expertise, right? And we're turning it into something very intuitive, which is a video. And so that's even, we're not going to focus on the motion amplification piece so much, but a lot of the flavor and a lot of the themes and the commonality between cameras and technologies is that this technology is that it allows visualization. It allows us to do things that we can understand a little bit better, because we're not at the mercy of a single point of data collection. So you can see misalignment instead of having to say, okay, well, the ratio of these two peaks is this amount, so therefore I think maybe it's this fault. Cameras also allow us to take advantage of the fact that there's millions of pixels in the camera. So instead of there being one sensor, there's millions of sensors, and you can leverage that fact and scale up your data collection to where you're taking 2-3 million data points instantly, all simultaneously. And if you were to try to do that with strain gauges or accelerometers or prox probes, that would be nearly impossible, and even dozens of those sensors becomes sometimes cost prohibitive and certainly cumbersome. So the idea of adding 1 pixel, 2 pixel, so on and so forth, that becomes a very very trivial thing with the camera, because it's just millions of sensors in the camera itself spread over an entire field of view. Just a little bit about the technical specs. We're going to go through some just introductory stuff for those that might not even be familiar with motion amplification. Its fundamental measurement is displacement. You can do all this live. The live motion amplification. It's that efficient in how you do it. Can amplify by a lot. You can see quite a bit of small motion. Any sort of level of motion. The spec there is at less than 0.01 mils. So we're talking about really hitting any range of motion for a variety of assets that really you would be interested in seeing. That's of significance in terms of sort of ISO standards or severity charts, that sort of thing. And we show an overall, right? So that's really key too, that you can watch all motions in the scene in that video that I showed. All motions are present, or you can separate out the frequencies. We'll talk about that a little bit. And you can kind of see there the frame rate, the frequency range that it operates in. Again, we're talking about displacement, so it's really a complementary tool to accelerometers down in the range where displacements are in the lower frequency. That's where the mechanical motion is. Two measurements, and everything's in phase. All these pixels are acquired simultaneously at precisely the same time. And so that's sort of key for doing phase measurements, cross-channel phase, that sort of thing, all capable. And then, of course, we'll focus on this a little bit more. It's the shaft displacement tool, the ability to make shaft displacements and the ability to be able to see shafts move as well as inspect them. And that's another tool or aspect of cameras that we're gonna show. So I'll talk a little bit in this talk a little bit more about the CM than I will than I have in previous talks if you've watched them before. But this is sort of the delivery system, right? That's the kind of way I look at it. You've got the irism, and then which is kind of the standard sort of camera. You can think of it as a standard camera that does the majority of the work. But if you ever need to go high speed, high frequency, the MX does that. That's really what that does, is it sort of allows you to go higher speed if you need to be able to see things that are moving faster. It has a higher frame rate in a nutshell. That's really what separates those. But the CM is sort of a different animal. Really, that the CM stands for continuous monitoring. And one of the reasons why I want to focus on that is because it can do things. You can do things with cameras that are pretty interesting when you start to do things like continuous monitoring. I mean, you can imagine, a lot of work is being done today in surveillance, and so you can see, there's 3 people in the field of view. This person entered from the left, this person entered from the right. The same person shows up in the video 5 times. There's a lot of work being done with continuous monitoring. We think of it as looking at a machine, but the entire world is using cameras in automobiles to pilot them and things like that. So I'm going to talk a little bit about that just sort of goes beyond to traditional motion amplification. A little bit about motion amplification, some of the benefits. We won't go too much in detail, but you can imagine a lot of these come from the fact that you're using a camera. So it's a root cause tool because you can cover such a large area in such a quick amount of time, and be able to look, really do a comprehensive look. It's a communication tool, produces videos, a non-contact, and you can do it while things in operation, that sort of thing. So it lends itself to a very diverse application set. And then I generally think of the camera more of setting up like a GoPro than I do of setting up sort of an analyzer, where it's really, in some sense, point and click. You focus it, you set the lighting, and then you move on. So really easy to use. I'm going to do some live stuff, even where from acquisition all the way to analysis here in a short bit. But again, actionable information. I mean, that's one of the things that I'm always about. If you can't do something with the information that you gather, the information doesn't have a lot of value to you. And so the key point, I think, with any technology is that if you can make an action based on it, that technology has value to you, if you're going to do something about what you see. So again, you can imagine there's a lot of variety of anywhere from structures and roller coasters to wind turbines and just simple motors and pumps that are pervasive everywhere. So just if you're a traditional vibration person, this is going to look familiar to you. Maybe this is your route where motor pump combination, or maybe a motor blower combination. You go through in this situation and you take, vertical, horizontal, axial, inboard, outboard, and you do that, right? And that gives you a lot of information about that asset. But the idea with the camera is you blanket this thing, and even a camera would be more thorough than this diagram that we've drawn, because every pixel, there's no gaps. Everything is collected. And so that's kind of the idea that we're doing here.
Agradecemos a atenção dada ao vídeo que iniciou esta série. Na próxima semana apresentaremos um vídeo que ilustra a possibilidade de filmagem, salientando movimentos em determinadas frequências e também como é possível neutralizar o movimento da própria câmera através da estabilização digital. Na era da indústria 4.0, a Vitek disponibiliza as mais avançadas tecnologias online, como análise de óleo, análise de vibração, de motores elétricos, que integradas permitem acompanhar o desempenho das plantas em tempo real e à distância. Acompanhe-nos nas redes sociais, LinkedIn, Facebook e YouTube, onde disponibilizamos palestras, trabalhos técnicos e vídeos para a sua atualização. Muito obrigado.